So 5.1, operations with polynomials. So this chapter is about polynomials and polynomial functions. So first, let's talk about a monomial. Have you guys ever heard of like a monocle? Like people, you know, those old time people who like bring up like one little lens to look at. So a monomial, I can't even talk. Monomial, one number. So mono, one, nomial is number, so one number. So monomial is a number variable expression that's the product of one or more variables with non-negative exponents. So it's going to be simplified when there's no powers of powers, when each variable only appears once, right? So you can't have x times x times x. Like, no. To simplify it, you'd write it as x cubed. And all fractions are in simplest form. There's no negative exponents. So a couple examples of monomials would be like 3. 3 is a monomial because there's no powers of powers. I mean, there's no variable, but there's no negative exponents. It's just a single term. X, that by itself is a monomial. You could have x times y. That's a monomial. It's one term. They're being multiplied together. And x squared. It's just one term. A constant is a monomial that are real numbers. So example of constants are like 2, half, -3, 1,000. These are all constants, and they can be a single term by itself as well.
Can you do decimals?
I mean, you could write it as a fraction.
Oh, so the monomials have decimals?
Sure. It's just a constant number. Yeah.
Monomial is 3 just an example?
Yeah. These are examples.
Are okay.
No, like, can it be, like, I thought you meant only 3.
No. I could write like 5, 6. Those are monomials because they're a single term.
Negative?
So any number.
Yeah.
Negative?
Yeah. Because I have -3 up there.
I don't understand constants.
So a constant is literally just a number. It doesn't have a variable in it. So if I have a monomial that's a constant, it doesn't have a variable.
So no.
What about like a 2 to the second?
2 squared?
Yeah.
It has to be in simplest form, so 2 squared would just be 4. You just write it as 4.
X squared?
What about like
You just write it as 9.
X squared?
You write it as x squared.
Okay.
Okay, let's determine whether these are monomials. I think this will help. Is -5 a monomial? Yeah. Yeah, it's just a single term.
No.
No,
Next one's no.
B, 4n squared.
That's yes.
Yeah, because they're just all being multiplied together. It's just one term. That's fine. How about this next one? 5 plus 3x?
No.
No. There's 2 terms, right? So 2 we call a binomial. Binomial.
So this is
So monomial just has one term. So the reason we're like being very specific about this is like what can we combine, like what can we multiply and combine versus add and combine. The idea is we're going to review Algebra 1, rules of exponents. How about number D, part D?
Yes.
Yeah, they're all being multiplied. This is just one term by itself. Okay, the degree of a polynomial. The degree of the polynomial is the degree of the monomial with the greatest degree. The degree of a monomial is the sum of the degrees of each variable. So we want to state whether each expression is a polynomial. If it is, state its degree. So is this first one a polynomial?
no.
No, how do you know?
It's 2 terms.
So that would be a monomial. Poly means many.
It's a binomial.
So it is a polynomial. Well, it has 2 terms, but it's not a polynomial because you can't have variables in the denominator. Yeah. Y to the -1 power is not a polynomial.
Wait, so you can't have variables in the denominator for it to be what?
For it to be a polynomial.
What about a binomial?
So a binomial means 2 numbers. Poly means many.
So
Poly, you
same
could have
thing
2
as
things. Right. All binomials are polynomials.
Okay, what about like a monomial?
And denominator. So if you look up above, it says that there's no negative exponents. So negative exponents means things on the bottom of a fraction. So technically, x over y is x times y to the negative 1, right? Y to the negative 1 is a negative exponent because it's on the bottom of a fraction. Okay, so let me be clear what a polynomial is. A polynomial, all the exponents of variables should be positive integers.
So basically, okay, for a polynomial, you cannot have a variable in the denominator.
Correct. So it should be positive integers. Let's look at this next one. So first, is this a polynomial?
No. Is there a negative?
Yes.
Yeah, because all the exponents are positive integers. There's no variable that's in the denominator. So we're good. So like this is one term, this is one term, this is one
Isn't
term.
that negative though?
There's a negative coefficient, but not a negative exponent. Negative coefficient right here, there's no negative exponent. So we know that this is a polynomial. So if I want to know the degree, you add up the, did I mess up? The degree of polynomial is the exponent of the monomial with the greatest degree. The degree of the monomial is the sum of the exponents of each variable. Sorry. So if I add up the exponent, 5 and 1 would be 6. 4 and 3 is 7. 1 and 1 is 2. The highest number is 7, so the degree of this polynomial is 7. Because you look at each term, each monomial, right? Each term by itself, add up all the exponents in each term, and that tells you the degree of the polynomial. We're going to have more practice with this.
Why isn't it, so for each monomial, you add up
The exponents
and then whichever one's the greatest?
would be the degree of the polynomial. Okay. Cool. So remember that an expression x to the n is called a power and represents a base, right? Our base is x, raised, multiplied by itself n number of times. So for example, if I have 3 to the 4th power, that means it's 3 times 3 times 3 times 3, right? 4 times. And if you multiply it out, you get 81. So, and just keep in mind, we're going to do a lot of like little problems today. And when the problem says simplify, what it means to simplify is you get rid of all the parentheses, you combine all the common terms, and you have no negative exponents. So how do you know you're done? If those 3 things are done, right? So if you can simplify your expression, so you get rid of all the parentheses, any common terms you combine, and you get rid of any negative exponents. That's the idea. Okay, so these are all the properties of exponents. I mean, I originally split them up, and instead I just put this table to save some space. We're going to go through each one. Instead of talking about it, we're just going to do an example where we actually use it to solve. So let's go ahead and let's simplify using product of powers. So product of powers means if you have the same base, you add the exponents. So for this first one, is this what you have? Is this the next thing on your page?
We have to remember all these.
Well, I mean, you have to know how to do it. I don't care if you know the name, but you have to know if I give you a problem like A, you have to know how to combine it, right? You don't have to have the name, but you have to know how to solve it.
If you say use this method.
I'm not going to say it. I only put it on there so that I remembered what to tell you to use to try to be organized when I was making my notes. Yeah. I kept coming back and restarting. So this was my way of being organized when I made this. Yeah. Because otherwise you'd be like, what? I was trying to be organized when I made the notes. So simplify using product of powers. Also wrote it so when you look at your notes, you can say, oh, wait, what thing did we use here? Normally, I'll just say simplify, and I'll give you some problems. Okay, so product of powers, if we have the same base being multiplied, you add the exponents. So I have x to the first, and I have an x to the fourth term. So if I combine them, I'll get an x to the fifth. Then I have a y to the second and a y to the third. If I combine them, I get y to the fifth.
So x to the fifth plus
X to the fifth times y to the fifth. Yeah, I want you to try B. Try out B.
We do the same way.
Yeah, it is. Notice that they're being multiplied. The bases are being multiplied, so you add the exponents. So
multiply the bases.
Yep. So we're multiplying the bases together,
What about the negative?
which means we add the exponents. Okay, so give it a try and see if you can do this one yourself. I'm going to poll you to see, we add the exponents. When you multiply the base of A, you add the exponents of 4 and 1. You're multiplying the bases of B, well, you add the exponents 2 and 6.
How is it 5?
Uh,
Where we go
4 plus 1?
the ones.
What? I don't know where you're
The
looking.
one's not. Is it not there?
Well, if it's not written, it's assumed to be an exponent of 1. How do we feel? Do we want to try another one? Yeah. Okay. So let me go through B. So first, I take a look and I grab my. Oops, it's not working. So first, I take my -3 and my 4. Those are the numbers, the constants. Combine them. -3 times 4 is -12. Then I look at my a to the fourth and my a. Well, if you just have a, the exponent's going to be 1. So when you're multiplying a to the fourth times a, multiplying the same base, add the exponents. So it'd be a to the 4 plus 1 or the fifth power. Then you look at your b squared times b to the 6. Well, you just add it, b to the 2 plus 6, which is 8. Then you look at your c. Well, no exponent, you assume it's 1 times c to the 7. So you just add your exponents and you get to the 8. Okay, try out c. Try out c on by yourself. I'm going to go through it on the board. So think about where you're getting confused, right? Are you getting confused? What's throwing you off? All right. So if you're done with that one, try out D. Try out D. So my hint to you about these two is you treat these as a variable when the bases match.
Well, did you want it? You wanted us to simplify so that
Yeah.
it's not gonna be.
Right. So at the end, we're actually going to get rid of the exponent. So you could either, there's two ways of doing it. I'll show you in blue the first way. So 2 plus 3, a 1 plus 2, b 1 plus 1. Because you could simplify the 2 to the squared and 2 cubed. You get the same answer. It doesn't really matter. So, your book says the blue way, right? Treat them as a variable, combine the exponents, whatever. If you want to simplify the numbers, 2 squared is 4, that's fine, because you end up multiplying them anyway. Okay, so fear not, because this is the most basic exponent rule, so you're going to have lots of practice with this rule in particular. Okay, so let's keep going. The next one, let's simplify using power of a power and power of a product property. Okay, what the heck does that mean? Power of a power. When you have a base, right, and the exponent is to an exponent, you multiply. But also, you have to keep in mind the power of a product property, you have to also distribute to every single item in your term. So notice this is not 2 plus a, it's 2 times a cubed. So you distribute the 4. So I have 2 to the 4th. Exactly. And let's see, 2 to the 4th times a to the 3 times 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. 16a to the 12th. All right, I want you to try out B. Give about 10 seconds or so, try out B, see if you can solve this one through. 1/4. All right, how do we feel about this so far? We're doing okay? Nice little, the cobwebs being cleared, having lots of practice. Okay, so, do you wanna do these two? Okay, sure. Let's do C. So these are totally different notes than last year because this is what people struggled with last year. So lots of review. This may take another day, but it'll be fine. So see, there's a lot of things going on. What's the very first thing that I should do, though? Ashton, do you know? What's the first thing I should do?
You should multiply the whole thing by 3 and the whole thing by 2.
Right, so using order of operations, right? Parentheses, exponents. So before I can multiply the 2 parenthesis things together, I have to deal with the exponents first. Does that make sense, what I was like trying to say? Okay. Yeah. I feel like I don't make sense sometimes. So I need to distribute out the 2 to every term here, and the 3, and then I could multiply them together. So let me just rewrite it. So I have -5 to the 3rd power, m to the 2 times 3, n to the 1 times 3, to the 3 to the squared, m to the 4 times 2, n to the 5 times 2. So we know what 5 times 5 is? 25. And if you have 5 quarters, how much money do you have? $1.25. Okay. So -120. You don't need your calculator. 6. Well, you do tomorrow for the hats. Okay, so we got this far. Are there questions what we've done so far? So I want you to try to finish the problem. Now that we've done the first part, right, distributing it out, huh? Yeah, exactly. Now that we're just multiplying across, you just add the exponents of okay, so for each variable, you have to like add them.
You add the numbers.
You multiply the numbers. Yeah. So, wait a little longer. The next one's a little tricky. Because you have an exponent to an exponent to an exponent. Oh my gosh. So, what I could do is I could multiply the power to a power.
Oh. So 3 times 2.
Mm-hmm. So let me rewrite this. So I have negative 3a times b squared to the 6th power. And then it's just distribute the exponent to every single term. So I have negative 3 to the 6th power, a to the 6th power, b to the 2 times 6. So negative 3 to the 6th power, that's kind of difficult. I don't know if I would expect you to know that. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729. Okay. You do need a calculator for that one. 729.
So you can't just do it like negative 3b plus 7, like parentheses 3, and then like.
Oh, so I think I see what you mean. So I'll do that. I'll do your way in blue. So you're talking about if I would distribute the negative 3 cubed like this?
Yeah. So that's what I did, but then I got negative.
Because you should get the same thing. So 9, negative 27, a cubed, b to the 6 squared. Negative 27 squared is 729 times a to 3 times 2 times b to the 6 times 2. So it turns out you get the exact same answer. Yeah. You do. Thank you for the reminder. I forgot to write that. There's a knowledge check that I assigned everyone. That'll be due Friday. Cool. It just starts the semester off by like seeing where you are, what do you remember. Nice comprehensive check. That way if you have a bunch of like hard things that you're struggling with, it will like catch that and have you learn them again. Also, if you messed up on the first knowledge check of the year, like push I don't know on every single one, that way it like puts you where you should be. All right, next we're going to talk about quotient of power property. So what that is if you have a division, you're dividing one by another. Do you remember what we do? So if you're subtract the exponents, exactly. So here I have a to the 8 minus 5, which is just a to the 3rd power.
If there's numbers, do you divide?
Yep.
What if it's like, I know we're gonna get to it, but what if it's like 7 on the top?
You still divide.
Like
You
a
still
No, like, say, like,
subtract.
the exponent or the number
Say like the 5 in the denominator for a is like a
was bigger, then you would write 1 over a. Because you don't want to write it as a to the negative 1 because we don't want negative exponents, right? So you write it as 1 over a. Yeah, because we are going to get to that soon. All right, let's try out b. I want you to try b. I don't know if this is working. I'm trying to have you guys like practice in class right now. Try it out. Right, after you check B, try out C. Try out C.
And if they're like the same.
They cancel.
So like will the whole variable cancel out or just like sorry?
The, like these.
No, like, well yeah, sure that one, but also like the B4 and B4.
Yeah, those totally cancel as well. Because if you have B times B times B times B over B times B times B times B, they all cancel out.
So I was thinking like what if P was like 1 over 1, that would still equal 1.
Yeah, because technically, well, because if you do, I guess I could just do this one right now. M to the 5 minus 4, N to the 1 minus 0, P to the 1 minus 1. So you get M, N, P to the 0. Well, P to the 0 is just equal to 1. So you just get Mn. Anything to the 0 power is 1. Except 0 to the 0. That's a very, very special case.
So anything that is the same denominator and numerator, it cancels out.
Yeah, if it's the same power. Like in D, the B cancels out. Yep. 14 over 21, a to the 5 minus 3, b to the 4 minus 4. So 14 over 21, can I reduce that? Exactly, 2 over 3 times a squared, and then b to the 0 is equal to 1, so I can just leave it alone. So I'll leave that. Cool. Yeah, let's keep going. Awesome. Simplify using power of a quotient property. Okay, so this is the exact same thing that we've more or less been doing. But if you have a quotient, you have the exponent, you distribute the square to every single term, not just the one on top. So, I can't read the numbers, my bad.
You're gonna say solve using quotient.
Nope. The only reason I wrote that is so that I can reference and tell you like which one specifically we're working on. I'm just gonna say simplify. And you have to know like the order and which one to use.
What just happened? I was like,
So power of a quotient property, if you look at the table on that page, like I'm telling you like which one to look at and I put them all in one place. Power of a quotient property is if you have x over y to some power, you can rewrite the whole thing to the power over the whole bottom to the power. Or what I can do, literally this is going to be the same thing as 6w to the 5th squared over 7p to the 6th s to the 3rd squared. So if you ignore the arrows that I drew, that's all this means. If I have the whole quotient, the whole division thing happening to a power, I can distribute the power to the top and the bottom. So I have 6 squared, w to the 5 times 2, over 7 squared, p to the 6 times 2, s to the 3 times 2. And since there's no variables, I can simplify on top and bottom, none cancel out. I can just leave it that way. I want you to try out B. So I'll give you about 15 seconds. I'm trying not to rush you. I want you to try B. All right, go ahead and check when you're done. There are a lot of properties, but it will be all good. Okay, so do we have questions over this one? No? So as long as you can follow it logically and like you try it yourself, it's just going to take practice. All right, so simplify using the zero exponent and negative exponent properties. All that means is like x to the negative 8 is the same thing as 1 over x to the 8. You get rid of a negative by putting the variable on the other side of the fraction. And the zero exponent property we talked about already, any number to the 0 power is 1. The only exception is 0. 0 to the 0, that's a whole other story. Like, we're not even going to talk about it. That's Pandora's box. You know what I mean when I say that? Pandora's box? Yeah, that's, ooh, not touching that one. I don't talk about it until calculus. I don't think I talk even with my pre-cal students, but I think it's like calculus we deal with it because that's special case. But any number to the 0 power, 1. So what I would like to do is combine this the way we've been doing, and then you're going to notice something sneaky happening. So I have my base, x to the third, x to the negative 8, and I want to add them. And then I have y to the negative 5th. I end up getting x to the negative 5th times y to the negative 5th. Well, that's okay, but that's not simplified. Remember, simplified means no negative exponents. So to get rid of the negative exponents, I move it to the other side of the fraction. So saying x to the negative 5 is the same thing as saying 1 over x to the 5th power, y to the 5th. That gets rid of the negative. Right, because saying y to the negative 5 is the same thing as saying 1 over y to the 5. That's the negative exponent, property we have to know. And whenever you're simplifying, you don't want negative exponents, you always have to move it to the other side of the fraction. Okay, let's try the next one. Yeah, I'm going to try to zoom out just a little bit. Okay, so that's weird. 12 to the negative 2. How do I get rid of the negative exponent? Move it to the other side. This is the same thing as 1 over 12 squared. And what is 12 squared? Yeah, so it's just 1 over 144. What? So this is an example. Like when you have a negative exponent, y to the negative 5th is the same thing as saying 1 over y to the 5th power. You get rid of a negative by putting it on the other side of a fraction. Yeah. So I got rid of the negative here by putting it on the other side of the fraction. Do you see on B? I got rid of the negative by moving 12 squared to the bottom of the fraction. So your question earlier about what if you subtract and you get a negative exponent, that's the next example we're going to talk about. So part C, I want you to try it out yourself. I'm going to give you a solid 15 seconds to try it out yourself before I go over it. I want to see if you can do it. So you're using just rules of exponents, right? We have a quotient, so we're going to be subtracting the exponents.
Wait, so repeat what you said about if the greater one is negative.
So if I end up with a negative at the end, you just have to put it in the other side of the fraction. Since I ended up with u to the negative 4, I can get rid of the negative by putting u to the 4th on the other side of my fraction. Right, because 0, anything to the 0 power is 1. How do I get the what? Negative 15 over 5 is negative 3.
No, why didn't you put W into why just the 16 over, why just 16 over 5, not the rest of it?
Because we can use the subtraction. So for u, there's 2 u's on top and bottom, and the way we simplify it is the same base, you subtract the exponents. That's why I'm taking negative 1 minus negative 3 right there. Yeah, only really the numbers we write that way I can see if I can simplify it at all. So at the end, since I had a negative exponent, I have to flip it to the other side. That's it. U to the negative 4 is the same thing as saying 1 over u to the 4. It's the exact same thing. You just take away the negative by putting it on the other side of the fraction. What if, you ready for a challenge problem? Yeah. That face says no. It's fine. What if I have 1 over u to the negative 2? How would I write this? Yeah, flip it to the top and get rid of the negative sign. Ah. Yeah, that was the trick I've been holding out on. If you have a negative exponent in the bottom, move it to the top. Change the sign. Move it to the other side of the fraction, change the sign. That's all you deal with negatives. Okay, let's try D. Let's try D. So there's a lot of stuff going on. It's a lot of stuff. So wait, is this the one I wanted to do? Yeah, let's do it. You distribute the exponent. Did you guys already do this? J to the 4, k to negative 12 over j cubed, k to the third. And then we just use rules of exponents since it's a quotient. Same base. When you have the same base, you subtract the exponents. So to get rid of the negative in the exponent, I just flip it to the other side.
Oh wow, I got it right. I did it.
Wait, so
Differently,
you
yeah.
do negative 12 minus 2.
Yep, negative 12 minus 3. So that's negative 15. Awesome. Yeah. K to the negative 15. And to get rid of the negative, I put it on the other side of the fraction. So this is the same thing as saying j times 1 over k to the 15, which I rewrite as j over k to the 15.
I thought if it's j over like k to the negative 15, you flip it.
But I don't have a negative on the bottom. I had a negative up here. So it's, when I have it as a line like this, it's negative. And so I got rid of the negative and the exponent for k by putting it as 1 over k to the 15. So I got rid of that negative by moving on the other side of the fraction. So there's really only like one-ish page of notes. Notice that there's a study guide. There's a whole page of study guide. That's just more problems for you if you have more questions. We're going to continue on more examples, but I just want to make sure you see the assignment. Okay. After, yeah, you should be able to do all the homework. Okay, let's keep going. Still got like 2 minutes. I'd like to do this one. So simplify each expression by combining like terms. Yeah, sometimes it doesn't print for me. Is that where they are?
Yeah.
So we combine like terms. So you only combine terms that have the exact same variables and exact same exponents. So these two are what I can combine. Negative x squared minus x squared is negative 2x squared. Then I'm looking for things with only an x. So negative 3x minus 2x is negative 5x. And then lastly, I see 4 minus a negative 5. 4 plus 5 is plus 9.
Negative 3x plus 2x.
What?
Negative 3x plus 2x.
Negative 3x. It's minus right here. So that's why I was going to say you could distribute the negative. This is one thing that we don't do a lot. So if you distribute the negative, you would get something like this. And then when you combine, you get the exact same answer.
You can do that.
Yeah. I actually recommend distributing the negative, otherwise you'll miss it, just like what you asked me. I think, is this the parentheses?
Yeah.
Okay. So there's only one term with x squared. There's only one term with x, and if you take negative 6 plus 1, it's just negative 5. This is probably a good place to stop. We'll start next class, and it'll take about, I don't know, 5 minutes or so, and we'll do page 6. Yeah. But you should be able to do the majority of your homework because it's mostly just rules of exponents. Cool. So I'll see you guys tomorrow. Take your extra minute to pack up and go to the bathroom or something. Don't be late for class.